We're wrapping up section 5.5, and one of the very important concepts to comprehend in economics is this consumer slash producer surpluses. A consumer surplus is the money gained by the customer for a certain commodity or service that they require. The difference between the consumer, which is the customer, that's the difference between what the customer is willing to pay and the actual selling price. And you find that normally by taking the demand function minus the price. The producer surplus is, on the other side, the gain by the entity or the company or the corporation that is producing the commodity or rendering the service. And that normally is the difference between the cost and the selling price. And you normally take price minus supply to figure that out. Now, if a new phone came out, a new cell phone came out, and the company, so once I hear a new phone came out, iPhone, Galaxy, whatever it is, in my mind I'm thinking, you know what, okay, I'm willing to spend $1,000 on it. If it comes up, if they come out and they say, okay, we're going to sell it right now for $1,500, well, most likely I'm not going to buy it. Few people will buy it, no matter what. Few people will buy it regardless. But in this case, the consumer surplus is a negative, meaning they're not going to buy it. The price is a lot higher than they're willing to pay. Versus, if I wanted to go buy a cell phone right now, and I know it's around $1,000. I went to T-Mobile last week, and they said, oh, if you trade in your old phone, we'll give you $500, $800. Well, guess what? That's a consumer service. I was willing to pay $1,000. Now I'm only paying $800. Now the money that you save, the difference is not really actual cash. It's the amount that you were putting in. That right there is what economists try to figure out. If they get a positive consumer surplus when they do those surveys, if they get that, customers feel as if their money has a lot of buying power. Whatever I want to buy, whatever I'm willing to pay, it seems things are cheaper, then I'm going to buy more. And normally that's a good indicator of a boost to the economy. It's very important to figure this idea out in economics. So the company surplus is really the difference between the price and the supply. It's right there. And the consumer surplus is actually the difference between the price and the demand. So if I'm looking at this, I would think of it this way. If I was looking at, and I'm going to give you this graph on the exam and the final. If I'm looking at it, I would go again vertical. If I'm looking for the blue part, which is the producer supply, I will take the top minus the bottom. The top, this is the actual price minus the supply. If I wanted to find this area, I will take the top, which is the demand, minus the bottom, which is the price. So the gray area would really be the demand minus the price, and the blue area would really be the price minus the supply. It's right there. So this I'm providing on your exam to help you. Now, how are you going to figure out what the price is? You set the demand equal to the supply, and that tells you the number of units that you need to produce and at what price. And once you figure that out, then that's really the price you're going to use in both of those. So here's our first example. I'm looking at this problem, and it says consumer and producer surpluses in 43 through 48. Find the consumer and the producer surplus by using the demand and supply. P is the price, in dollars, and X is the number of units. Will supply demand depend on the price, and supply function depend on the price, and demand function depend on the price. If I really wanted to find the consumer surplus, well, before I begin, I need to figure out what the price is, and you have to do that in every problem. I need to figure out when would the demand equal the supply, and that is when 300 minus X equal 100 plus X, that is 2X equals 200, or X equal 100. I just figured out that the equilibrium happened when I produce 100 units. What would be the price? Whether you use this or this, it makes no difference. The price would be $200. So I just figured out the equilibrium happens at $200. So now I know what to do. If I want to figure out the consumer surplus, I will take the integral from 0 to 100 units. That's why I need to know where that is. Of what? And since I'm giving you this, if you're looking for consumer, I'm looking at the gray area. That's the top. That's the demand function. Do you see where the demand function is? It's right there. The demand is 300 minus X minus, and do you see the bottom is the price? What would be the price in this case? The price is $200. Solve that and I'm set. And if I want to know, this is the consumer, if I want to know the producer surplus, I would take the integral from 0 to 100 still, finding that area. And if I look at the producer surplus, I'm looking at the top, which is the price. The price is $200 minus the demand, the supply function, and the supply function here is given by 100 plus X dx. And there it is. That would be the setup. And if I work this out, I'm looking at, this is 100 minus X, right? So that would be 100X minus X squared over 2 evaluated from 0 to 100. That would be 100 into 100 minus 100 squared over 2 minus 0. And that would be 100 times 100 minus 100 squared divided by 2. $5,000. And if I want to figure out, let me see how I can squish this in without making a big mess. And if I want to figure out the producer surplus, that's really that's 100 minus X dx, and that turns out to be 100x minus x squared over 2 evaluated from 0 to 100. It happened to match. That's not always the case, you guys. Just a coincidence. So the producer surplus is 5,000, the consumer surplus is 5,000. If I look at the next problem, the same deal. First, I want to figure out the equilibrium. I want to figure out where is the x sub 0 and y sub 0, that x sub 0 and that p sub 0 instead of y. So again, I'll set 975 minus 23x equal the 42x. Basically what I'm doing, I'm setting the supply equal to the demand, and I solve that. I'll get 975 equal, what is that, 65x. So x would be 975 divided by 65, 15. So I figured that the number of units is 15, and the price either here or here, you should get the same answer. It doesn't matter. If I take 42 times 15, I'll get 630, and if I take 975 minus 23 times 15, I'll get also 630. So the price is 630, and the number of units would be 15. I need both of those to do the problem. First, if I want to figure out the consumer surplus, I need to take the integral, and again, I'm providing this. I'm just reinforcing this so you could see it over and over. So if I really look at consumer, it's the top. It's the demand minus this line, which is the price. It's the demand minus the price. The demand in this case is 975 minus 23x minus the price. The price is $630. And to find that area, I'm going to integrate from 0 to 15 because that's the x value. And I'm going to set up the producer surplus. And remember, the producer surplus is the difference between how much are they paying to make the commodity and how much are they selling it for. But if I look at the graph, that is the top, the line is the price minus the supply. The price minus the supply. Well, the price is $630 and the supply is right there, 42x dx. If I find these areas, I'm in good shape. That is the integral from 0 to 15. And what is that? 975 minus 630. That is 345, I think. Yeah. Minus 23x dx. That would be 345x minus 23x squared divided by 2 evaluated from 0 to 15. That would be 345 times 15 minus 23 over 2 times 15 squared minus 0. So the consumer supply would be 345 times 15 minus 23 times 15 squared divided by 2. 25.87 and 50 cents. So that's a good thing if it's positive. And here, 0 to 15 as well. Again, we need to know how many units. Here, that would be 630x minus 42x squared divided by 2 evaluated from 0 to 15. That would be 630 times 15 minus 2 divides 42 21 times 15 squared. And that would be 630 times 15 minus 21 times 15 squared. 4725. So as long as these numbers are positive, the consumer is very happy because they're being able to buy more, and the what do you call it? The producer is happy because they're making profit. Now, of course, the more they charge, the more they make. But then, there's a balance, because if they go too high, then they lose money because they're not going to sell enough units. On the following problems, there are a couple of ways that you want to use common sense to really get you going with this. It says two models, and this happens all the time. Two models, R1 and R2, are given for revenue in billions of dollars for a large corporation. Both models are estimates of revenues for 2020 to 2025. So they're figuring out what they're going to do in the future, and these are estimates for how much revenue they're going to have. T equal 20 correspond to the year 2020, so T equal 25 correspond to the year 2025. Which model project a greater revenue? How much more total revenue does the model project over the 6 period? The 6, because 2020 is 1, 21 is 2, 2020 is 1, 21 is 2, 22 is 3, 23 is 4, 24 is 5, and 2025 is 6 year. So this is how we could do this. we could say, you know what? Take the integral from 20 to 25 and take R1 minus R2, and I'll tell you what that means in a minute. Take R1 already made a mistake. Minus R2. So I'm really taking R1 minus R2, and R2 is 7.21 plus 0.1t plus 0.01t squared, all with respect to t. And this is the idea. If my answer is positive, that means R1 is bigger than R2. If my answer is negative, that means R2 is bigger than R1. Does that make sense? If R1 is 10 billion and R2 is 8 billion, when you subtract those, you're going to have 2 billion, which means R1 is bigger when you subtract two quantities. If I take this to be 8 billion and this to be 10 billion and I subtract those, it's going to turn out to be negative. So if it's negative, R2 is bigger. If it's positive, R1 is bigger. And this is nothing more. 7.25 minus 7.25 cancel out. 0.26 minus 0.1 is 0.16t. And 0.02 minus 0.01 is 0.01t squared. And that's pretty much the whole problem. So this is 0.16 times t squared over 2 plus 0.01t cubed over 3, evaluated from 20 to 25. That's going to be 0.16 times 25 divided by 2 plus 0.01 times 25 cubed over 3 minus 0.16 over 2 times 20 plus 0.01 times 20 cubed over 3. And if I, 0.2 squared, right? If I throw this in my calculator, I will get a total of, and let's do this. If I plug the first one, 0.16 times 25 squared divided by 2 plus 0.01 times 25 cubed divided by 3 minus parentheses. If I take 0.16 times 20 squared divided by 2 plus 0.01 times 20 cubed divided by 3. I'll get the answer to be 43.42 billion. So my answer will be R1 is greater. R1 projects. R1 projects right there. A greater revenue by how much? By $43.42 billion. So a massive difference. The next problem is not really an economics problem, it's more of a pandemic, but since we are in this problem, since we are in this outbreak, I thought it should help. An epidemic has spread such that T weeks, so T is in weeks, after the outbreak, it had infected that many people. And they're doing this over 50 weeks. 52 weeks is a whole year. 25 weeks after the average. So this ran for 25 years. For 25 weeks. 25 after. So this is introduced from 25 weeks until the end. 25 weeks after the outbreak, a vaccine was developed and administered to the public. At that point, the number of people infected was governed by this, so it changed the way it works. This is how it was infecting people. Now this is how it is infecting people. Approximate the number of people that the vaccine prevented. To figure this out, you would say, okay, well look, if I find the total that would have been infected, since we're talking about the vaccine, so it has to be at 25 when it was introduced, to 50. If the vaccine would not have been invented, people would have been infected at this rate. Since the vaccine was invented, it's gonna really save that many people. So, instead of me figuring out how many people would be infected in the last 25 years versus how many would have been infected and subtract the two, I could do that one shot. That's what integrals do. It'll find that total that would have been infected without the vaccine, now with the vaccine, and subtract the two, and that gives you how many people did the vaccine actually prevent from being ill. And that's how they figure out all of these numbers nowadays. So if I distribute that in, that's plus 0.1 plus 0.2 is 0.3 t squared. 0.5 minus 6 is negative 5.5 t. 150 minus 200 is negative 50. It's dt. So this would be 0 from 25 to 50. So 0.3 t to the third over 3 minus 5.5 t squared over 2 minus 50 t evaluated from 25 to 50. So this is a 0.1. This will be 0.1 times 50 cubed minus 5.5 over 2 times 50 squared minus 50 times 50 minus 0.1 times 25 cubed minus 5.5 over 2 times 25 squared minus 50 times 25. And this turns out to be, and again, a calculator is essential here. So if I take 0.1 times 50 cubed minus 5.5 times 50 squared divided by 2 minus 50 times 50, that's the first parentheses, minus parentheses 0.1 times 25 cubed there. No. 0.1 times 25, okay, that's better, cubed minus 5.5 times 25 squared divided by 2 minus 50 times 25. And let me just 12,968.75. We're talking about people. So what does that mean? You run to the nearest number. So you say approximately 12,969 people okay, you know what, let's put it in the same order so I don't change the wording here. Approximately the vaccine prevented approximately here. I'll write it here. That's okay. 12,969 people from becoming ill. And there's your homework.